Okay, so first things first, electron configuration. We gotta learn how to draw the chart. Draw a grid. All we're doing is drawing a grid. First things first, draw the grid. Second things second. We gotta remember SPDF. SPDF. This is the order of all of the orbital notation and all of the electron configuration. We gotta make sure it's SPDF. How I remember it? It's SPDF, like the document type. Now, next we gotta number all the rows. 1, 2, 3, 4, 5. You will not go past 5. If you do, you're crazy. Anyway, now, here's what we're gonna do. It's in a triangle pyramid going down and to the right. So, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. So it goes down and to the right. Now, here's how we use this. This is weird and complicated, so I'm going to bring you a little closer. So, we go like this. We start at the very top. We're going to go down and to the left, just like this. This is why we use the grid, so we can start right here and just go down the diagonals. So the first things first, we start at the very top left with 1s. So I'm going to do the order first, and then we'll do what they mean. So the first things first, 1s, 2s, 2p, 3s. Then, after 3s, we go to the next diagonal.
Oh, heck no. Oh.
Shh. After 3s, it's 3p, 4s. After this, we go down the next diagonal. We keep on doing this until we hit whatever we end up with. We'll talk about that in a second. Next is 3d, 4p, and then 5s. Now, if you go past 5s, you may have a really high elemental number. So, remember, the number of electrons is the atomic number, plus or minus depending on the variant. So, if you have a normal oxygen atom that has 8 protons, 8 neutrons, and 8 electrons. So we're going to use the electron configuration that has 8 electrons. So, to do this, we have to know how many electrons are in each of these parts. So, S will always contain exactly 2. It can hold up to 2. P can hold up to 4 more than that, which is going to be 6. D will hold 4 more than that, which is going to be 10. And then F can hold 4 more than that, which is going to be 14. You can remember it this way. S is 2, everything else is plus 4. Now, here's how we actually use this. Finally, we have 8 total electrons. Well, S can hold exactly 2, so we need to use all 2. So we're going to say 1s2. This means how many electrons are in that part of the system. Now, the next part, we still have 6 electrons left. So we're going to say 2s2, because that's the next part of the sequence. Now, we just used 2 more electrons, so now we're left with 4. When we are left with a number of electrons that is not 0, we have to make do with what is left. So P can hold 6 total electrons, but we only have 4, so we have to make sure we only produce 4. So it's going to be 2p4. Now this is important because if you say 2p6, you're not talking about oxygen anymore, you're talking about a completely different element. Now, we're going to do the same thing but with sulfur. Sulfur has an atomic element number of 16. So we're going to do the same thing over here. So, first things first, we got to make sure we follow our order. 1s. We have 16 total electrons. Hey, I need y'all to be quiet. I'm doing a video. We have 16 total electrons. S holds 2. We're going to use 2 of them. Now we have 14 left. The next part is going to be 2s. S still holds 2 electrons, so we're going to use 2 of them. We're left with 12 electrons. Now, we keep on going. 2p. P holds 6 electrons, so we're going to say 6. Now we're left with 6 more electrons. We are almost done. Next thing in this is 3s. So I'm going to write 3s S holds 2. We have 6 left, so we're going to put those 2 right here. Now, next is 3p. 3p. We have 4 electrons left. That means we're going to put all 4 of these into p since p holds more than 4. So, 3p4. This is the electron configuration for sulfur. Now, there's one more thing we got to know. We have to know about the orbital notation. Orbital notation is very simple. You take your electron configuration, and we're going to draw arrows based off of everything that's very simple. That'll make the cut. Okay, so here's what we're going to do. We're going to take our electron configuration. We're going to draw boxes below each of these sections. So the most important thing is, at most, half of them are going to go up, and at most, half of them are going to go down. So here's what we're going to do. S has 2 electrons. If we have 2 total electrons, one's going to go up, one's going to go down. So one goes up, one goes down. Here we have 2s2. One's going to go up, one's going to go down. Now, here, we have to put as many up as we can first, and then put the rest down. Since we have 4, 3 are going to go up, because we can put at most 3 up. 1, 2, 3. And then we put the rest going down. 1. Since we only have 4, we can only put in 4 total. Now we're going to do the same thing for sulfur. Sulfur is going to be a little bit longer just because it's a higher element number. So we have 1s, 2s, 2p, 3s, 3p. Let's go ahead and do that now. First one, 1s2, 1, 2, 2s2, 1, 2, 2p6. We have 6 total electrons, half go up, half go down. 1, 2, 3, 1, 2, 3. Now, 3s2, 1, 2. Same thing here. We put as many as we can going up. We can have at most 3. We have more than 3, so all of them are going to go up. 1, 2, 3. And then the rest are going to go down. 1. So this is how we do electron configuration and orbital notation. The most important part is remembering how to draw this chart. If you need to review, go back to the beginning of the video. Thank you for watching.